Hi, this is Thomas. Welcome to Algebra. Today's topic is quadratic inequalities. Quadratic inequalities have similarities to quadratic equations. So let's begin with an example, and we'll work through the process as if we were solving an equation, and then observe what adjustments we need to make to our process. Our first example is 3x squared plus 5x is greater than or equal to 2. So I want to set the right side of the inequality, as I would with an equation, to 0. I'll subtract 2 from both sides. 3x squared plus 5x minus 2 is greater than or equal to 0. Now when I factor this equation, you might be able to do this with manual factoring, or you might want to use the quadratic formula. Our factors end up as 3x minus 1 and x plus 2 greater than or equal to 0. Now the x values represented by these factors are 1/3 and -2. And if we were dealing with an equation, these would be our solutions. In the case of an inequality, what we're going to do is create a sign diagram including both of our solutions, -2 and 1/3. -2 and 1/3 are our critical points, and we want to evaluate what's happening to the inequality on either side of the critical points. So I'm going to select a test point in each of these three sections of the sign diagram. Something to the left of -2, less than -2, we can use -3. Something between -2 and 1/3, we can use 0. And something greater than 1/3, we can use 1. Now let's input these test values into the equation and see what output we get. And I'm going to use the factored version of the equation in my analysis. So 3x minus 1 is 3 times -3 minus 1 times x plus 2. -3 plus 2. Now what we're looking for isn't the precise result, rather the sign of the result. So notice that we're multiplying two values. 3 times -3 minus 1 is a negative value, times -3 plus 2 is a negative value, and our result is a positive. Negative times negative is positive. Now we'll evaluate the meaning of that positive in a moment. For now, let's continue on to consider 0 as a possible value of x. In evaluating 0, I won't write out the entire process. I'll simply identify the sign of each of the expressions. 3x minus 1 would be 3 times 0 minus 1, which will be a negative value, multiplied by x plus 2, 0 plus 2, will be a positive value, and negative times positive gives a result which is negative. Let's do the same with our third test point, 1. 3x minus 1. 3 times 1 minus 1 will give us a positive, multiplied by x plus 2 is 1 plus 2, which is positive. Positive times positive results in positive. Now that we have the three signs of our test points, we can evaluate these three sections of the sign diagram. So what are we evaluating? Looking at the equation, we've set the equation equal to 0. And the two factors that we're evaluating, 3x minus 1 times x plus 2, should give a result greater than 0. So we can evaluate the statements: a positive number is or is not greater than or equal to 0. A negative number is or is not greater than or equal to 0. And again, a positive number is or is not greater than or equal to 0. And now the evaluation. Yes, it is true. Any positive value is greater than or equal to 0. Second, it is not true that any negative value is greater than or equal to 0. And third, yes, again true. Any positive value is greater than or equal to 0. So looking back up at the sign diagram, the sections that do result in a true statement are the left of -2, including -2, and the right of 1/3, including 1/3. And we can write those sections of the sign diagram as x is less than or equal to -2, or x is greater than or equal to 1/3. These are the solutions for the inequality 3x squared plus 5x is greater than or equal to 2. Let's look at a second example. X squared plus 9 is less than 6x. We begin by setting the equation equal to 0, and we'll subtract 6x from both sides. X squared minus 6x plus 9 is less than 0. We can now factor x minus 3 times x minus 3 is less than 0, and the relevant x values are 3 and again 3. So we have one critical point in this inequality. We'll set up our number line and mark off x equals 3. Now we can select two numbers for evaluation, one on each side of 3. We can test 2 and 4. In evaluating 2 first, x minus 3, 2 minus 3 is a negative value, times, again, a negative value. Negative times negative is positive. And with 4, x minus 3, 4 minus 3 is positive, times, again, the same value, positive. Positive times positive is positive. Now the two statements we're evaluating, a positive number is less than 0, a positive number is less than 0, which are both the same statement, obviously. Both are not true statements, and our result is no real solutions for the inequality x squared plus 9 is less than 6x. This concludes the lesson on quadratic inequalities. In our following lessons, we're going to expand our understanding of quadratics to consider the concept of a quadratic function.